October 14, 1943, a Thursday afternoon over central Germany. 291 American B-17 Flying Fortresses crossed the sky in tight formation. Below them, the ball-bearing factories of Schweinfurt. Above them, nothing. No fighter escort, no cover, just 25,000 feet of thin, cold air and the sound of nearly 1,200 Wright Cyclone engines pulling 30 tons of aluminum toward a target they will never all leave. The Luftwaffe is already climbing. Focke-Wulf 190s, Messerschmitt 109s. They know exactly where the American fighters turn back. They have watched them turn back for months. In one of those bombers, a young man from Ohio or Texas or Nebraska watches the German fighters climb toward him. He is 22 years old. He will not be 23. By the end of that afternoon, 60 American bombers will be gone. 600 crewmen dead, missing, or in German hands. Another 140 aircraft will limp home shot to pieces. It is the second Schweinfurt raid. It will be remembered as Black Thursday. And within a week, the United States Army Air Forces will suspend deep penetration daylight bombing into Germany. The men who planned this war have run out of answers. They have the bombers. They have the crews. They have the factories. They do not have the one thing that keeps young men alive over Berlin. They do not have a fighter that can fly that far. The answer to Black Thursday is not being built in a factory that makes airplanes. It is being built in a factory that makes luxury cars in Detroit, in a plant on East Grand Boulevard that 3 years earlier had never manufactured an aircraft engine in its history. And the engine coming off that assembly line is not American. Not really. It is British, redrawn, retooled, rebuilt from the first bolt to the last, line by line, in a language Detroit had to teach itself to read. This is the story of that engine, and of the men on 2 continents who spent 4 years arguing about it, testing it, funding it, dying in it, and finally sending it to Berlin. The airplane arrived first. In April 1940, the British Purchasing Commission walked into North American aviation in Inglewood, California, and asked for fighters. What they got 117 days later was a prototype called the NA-73X, a single-seat, low-wing monoplane with something almost no fighter in the world had. A laminar flow wing. Air moved across it in smooth, unbroken layers. Less drag, more speed, more range per gallon of fuel than anything the Royal Air Force flew. Under the belly sat something equally new, a radiator scoop, not just a hole for cooling air. A carefully shaped duct designed on principles worked out 5 years earlier at the Royal Aircraft Establishment at Farnborough. An English engineer named F.W. Meredith had shown that if you fed cooling air through a properly designed duct, the heat you dumped into it produced a small amount of thrust on the way out. The engine cooled itself and gave you a little push in return. On paper, it was a curiosity. On the Mustang, it was worth miles of range. The RF called it the Mustang Mark I, and when they flew it, they were impressed, to a point. Below 15,000 feet, the Mustang was faster than a Spitfire. Above 15,000 feet, the Mustang began to die. The engine was an Allison V1710, American 12 cylinders, liquid-cooled, a fine piece of machinery at low altitude, but it had one supercharger, one stage, one speed, and above 15,000 feet, that supercharger could no longer stuff enough air into the cylinders to keep the engine breathing. Horsepower fell, speed fell. By 25,000 feet, where the German fighters lived, the Mustang was gasping. The RAF made a decision. They sent the Mustang down to the deck, Army Cooperation Command, low-level tactical reconnaissance, photograph the French coast at treetop height and come home. The best fighter airframe in the world was being used to take pictures. 3,000 miles east in Derby, England, the answer to that problem already existed. The Rolls-Royce Merlin, a 27-liter V12, first run in 1933. By 1940, it was inside Spitfires and Hurricanes and Lancasters and Mosquitoes. And inside it, a mathematician was working. His name was Stanley Hooker. 33 years old in 1940. Oxford graduate, applied mathematics, no formal training in aero engines when he arrived at Rolls-Royce in 1938. He looked at the Merlin supercharger intake duct and told his superiors it was strangling the engine. He redesigned it. He kept redesigning. By 1941, Hooker's supercharger group had produced something extraordinary. 2 stages, 2 speeds, an intercooler between them to stop the compressed air from boiling. A Merlin with the Hooker supercharger could pull full rated power at over 20,000 feet and hold useful power far higher than the Allison ever could. That engine did not exist in America. Nothing like it existed in America. And Britain could not make enough of them. In September 1940, while German bombs fell on London every night, Rolls-Royce factories in Derby, Crewe, and a new plant outside Glasgow ran 24 hours a day. Between them, they produced roughly 200 Merlins a week. The Air Ministry needed far more than Britain alone could build. Every Spitfire needed one. Every Hurricane needed one. Every Lancaster would need 4. Every Mosquito would need 2. The math did not work. The British government looked across the Atlantic. They went to Detroit first. June 24, 1940, a telephone call. William Knudsen, Danish-born, 61 years old, former president of General Motors, now running America's industrial mobilization for President Roosevelt, calls Max Gilman, president of the Packard Motor Car Company. Knudsen asks Gilman and his chief engineer to meet him at his house on Grosse Isle in the Detroit River. That same day, they go. Knudsen makes them an offer, 9,000 Rolls-Royce Merlin engines, 6,000 for Britain, 3,000 for the United States Army Air Corps. Would Packard consider it? The chief engineer sitting across from Knudsen is a man named Jesse Vincent, 60 years old, vice president of engineering at Packard for nearly 30 years. During the First World War, he had co-designed the Liberty V-12, the aircraft engine that had put America into the air war. His military rank colonel came from that. He still used it. Vincent tells Knudsen that Packard will consider any proposal. Knudsen flies to Washington that afternoon. But there is a detail Knudsen has not told them yet. Packard is the second choice. The first choice was Ford. In the early summer of 1940, Henry Ford himself had agreed to build the same engines, 9,000 of them. Ford had accepted delivery of Rolls-Royce blueprints and at least one complete Merlin engine as a manufacturing reference. And then Henry Ford, 76 years old, isolationist by conviction, changed his mind. He announced that the Ford Motor Company would not produce war material for any foreign power engaged in the current conflict. The irony would take years to reveal itself. Ford of Britain, at Trafford Park outside Manchester, would eventually build over 30,000 Merlins for the RAF. But the American Ford Motor Company would not build a single one, which is how Packard, on a summer afternoon in Grosse Isle, inherited a contract that Henry Ford had thrown away. 6 weeks later, on August 2, 1940, 3 men arrived in Detroit from Derby, England, Rolls-Royce engineers, sent to walk the Packard men through what they had agreed to. The first thing they asked Jesse Vincent was a technical question. They wanted to know whether Packard intended to tool up for a 1-piece cylinder block or a 2-piece cylinder block. Vincent had never heard of a 2-piece cylinder block. The British engineers unrolled their drawings. They explained politely that Rolls-Royce had recently developed an improved 2-piece design. They recommended Packard build to that specification. The room was quiet for a long moment. The men who had come to Detroit expecting to teach the Americans how to build a British engine had, in the first hour of the first meeting, just introduced Detroit to something Detroit had never seen. The contract was signed on September 3rd, 1940, $130 million, nearly $3 billion in today's money. The largest single engine manufacturing contract in American history to that date. And then the crates began arriving at East Grand Boulevard. Complete Merlin engines. Hundreds of blueprints and imperial measurements Detroit did not recognize, threading specifications from a British system called Whitworth that no American machine shop had the tooling to cut. Tolerances written in the assumption that a skilled fitter would file the parts until they matched. And behind all of it, a philosophy of manufacturing that treated every engine as an individual piece of work, tuned by hand, tested by feel, signed off by a craftsman who had learned his trade the way his father had. Packard's engineers unpacked the crates. They spread the drawings across their tables. They began to read, and they realized very quickly what they had actually been asked to do. The problem was not metal. The problem was language. The blueprint spoke English, but not the English Detroit spoke. Rolls-Royce measured in inches. So did Packard. But the inch a British draftsman drew in 1940 was not quite the inch an American machinist cut in 1940. The British engineering tradition carried decades of its own conventions, fits and clearances written in tables that assumed the reader had grown up inside a Rolls-Royce shop. Radii and chamfers marked with symbols, Detroit had to look up. Every drawing had to be studied, argued over, and in the end, redrawn. Packard put roughly 200 engineers and draftsmen on the project. They worked in shifts, tables lit under green-shaded lamps, Rolls-Royce liaison men from Derby standing at their shoulders. It took the better part of a year. The entire Merlin, every casting, every forging, every shaft and gear and rocker arm was drawn again in the language of American mass production. Not because the British drawings were wrong, because they were incomplete. They assumed a skilled human being would finish the job. Detroit did not build engines that way. In an American automobile plant, a crankshaft came off the line at a specified diameter, plus or minus a few 10,000ths of an inch, and it fit any block in the building. No filing, no fitting, no craftsman deciding by feel that the part was ready. This was not a lower standard than Rolls-Royce. It was a different standard, and it was the only standard that produced engines by the hundred every week. The Packard engineers began to change things. The main bearings came first. Rolls-Royce used a copper lead alloy that had served the Merlin well, but demanded careful break-in and frequent inspection. Packard's metallurgists, drawing on research from General Motors' Pontiac division, proposed a silver lead bearing plated with a microscopic layer of indium. The silver carried the load. The indium sealed the surface against the corrosive wartime lubricating oils that had been eating British bearings for months. The Rolls-Royce men objected at first. This was not the specification. Testing settled the argument. The Packard bearings ran cooler, lasted longer, broke in faster. Within a year, Rolls-Royce was adopting the American bearing for their own engines in Derby. The carburetor came next. British Merlins used an SU carburetor with Whitworth threads. Packard specified a Bendix pressure carburetor, an American design, with American unified threads. This was a real change, and it mattered. Later, in fighters pulling negative G in a dive, the Bendix would keep feeding fuel where the SU could momentarily starve. Colonel Vincent designed pieces himself, an automatic speed change mechanism for the two-speed supercharger drive, an aftercooler that squeezed a little more efficiency from the compressed air. He patented both. Late in the war, he would design a three-speed supercharger drive that never went into production because the war ended first. But here is the part of the story that has been told wrong for 80 years. Packard did not switch the Merlin to American threads. You have heard, perhaps, that the Americans arrived in 1940 and modernized a British engine, and that part of that modernization was replacing the odd 55-degree Whitworth threads with clean 60-degree American unified threads. It sounds right. It sounds like the way the story should go. It is not what happened. Packard reproduced the Whitworth thread system exactly. British Standard Whitworth for the coarse threads. British Standard Fine for the precision connections. British Standard Pipe for the fluid fittings. and British Association for the smallest instrument screws. Every tap, every die, every gauge, custom manufactured in Detroit to cut a British thread form to American automotive tolerances. Why? Because a Packard Merlin had to be interchangeable with a Rolls-Royce Merlin. Not in the abstract, in practice. On a grass airfield in Lincolnshire, on a coral strip in the Solomons, on a hard runway outside Casablanca, a maintenance sergeant had to be able to open a crate stamped Detroit and pull out a connecting rod that would drop into an engine stamped Derby. Most of the engine was that way. The head bolts, the cam covers, the accessory drives. Detroit spoke Whitworth so that a Rolls-Royce Merlin and a Packard Merlin could speak to each other. There were exceptions. The Bendix carburetor kept its American threads. So did a handful of American-sourced accessories. But the heart of the engine, the pressure vessel that had to hold together at 3,000 revolutions per minute for 1,000 hours between overhauls, spoke the same mechanical language on both sides of the Atlantic. Which brings us to the argument that will not die. Somewhere in the middle of the war, a Rolls-Royce engineer named Stanley Hooker met a Ford engineer at Ford's Trafford Park plant near Manchester. Hooker told the story himself years later in his memoir. The Ford man complained about the Merlin drawings. Hooker assumed he meant the tolerances were too tight for mass production. He said as much. The Ford engineer corrected him politely. The tolerances, he said, were too loose. Ford could not build engines to Rolls-Royce drawings because the drawings allowed too much variation for what Ford considered mass production. That story, retold and retold and retold, has calcified into a legend that Rolls-Royce built Merlins by hand, one at a time, each one filed to fit by skilled craftsmen, and that Packard came along and taught the British how to actually manufacture things. The legend is wrong. Rolls-Royce built more than half of every Merlin ever made, 26,000 at Crewe alone, tens of thousands more at Derby and Glasgow. The Glasgow plant, Hillington, was staffed largely by women who had never assembled anything more complicated than a household appliance before the war. You do not produce 40,000 engines with unskilled labor by hand filing every part. It cannot be done. It was not done. The document exists. It sits today in the National Archives at Kew, cataloged as Air 10/2175. Merlin 1 Aero Engine, Part 2, Schedule of Fits, Clearances and Repair Tolerances. Dated October 1938, 2 years before Packard signed the contract. Every dimension, every allowance written down. Not hand-fitted, specified. The truth is more interesting than the legend. Both companies mass-produced the Merlin. Both did so brilliantly. Packard's manufacturing systems were more streamlined, more automated, more Detroit. Rolls-Royce kept certain shop practices, particularly the way they match-drilled bolt holes through assemblies. That made total parts interchange harder. Neither company was building watchmaker's art. Both were building weapons, at scale, under bombs, against a clock. And while Detroit and Derby fought about tolerances on an April afternoon in 1942 at an airfield called Duxford, one flight of 30 minutes was about to change the war. Duxford, north of London, April 30th, 1942. A Rolls-Royce test pilot named Ronald Harker, 32 years old, walks out to an American fighter borrowed from the Royal Air Force Air Fighting Development Unit. The airplane is a Mustang Mark I, serial number AG422. The engine is the Allison. Harker has been invited by Wing Commander Ian Campbell Ord, 42 years old, the unit commander, an old friend. Harker straps in, starts the Allison, taxis, takes off. He is airborne for 30 minutes. When he lands, he is quiet. He has been flying Spitfires for a living. He knows what the Spitfire feels like. He knows what a Messerschmitt 109 feels like from combat reports crossing his desk. And he knows after 30 minutes that the Mustang he has just flown is below 15,000 feet, superior to the frontline Spitfire 5. Cleaner airframe, longer range, faster. Above 15,000 feet, the Allison chokes and the Mustang becomes ordinary. Harker walks into the office and writes a letter. He sends it the next day to Rolls-Royce. He suggests fitting the Mustang with a Merlin 61, the two-stage engine, the Hooker engine. He believes the resulting airplane will be, in his words, outstanding. Ronnie Harker is not a famous man. He is not a general. He is not a designer. He is a service liaison test pilot for Rolls-Royce based at Hucknall, and his job is to help the Royal Air Force get the best out of the engines his company builds. He has just, on a whim, on a favor to a friend, on the strength of 30 minutes in an airplane he does not own, written the letter that will bring the P-51 Mustang to Berlin. His superiors listen. On the 14th of May, 1942, Ernest Hives, general manager of Rolls-Royce, 56 years old, a man who had started as a fitter and worked his way to the top, sends a secret memo to the Air Ministry. He proposes fitting several Merlin engines into Mustang airframes for full flight evaluation. The Air Ministry says no. Every Merlin 61 coming off the line is spoken for. All of them are going into the new Spitfire 9, being rushed into service to counter the German Focke-Wulf 190, which has been slaughtering older Spitfire 5s all through the winter. There are no engines to spare for an American airframe that the Royal Air Force has already relegated to taking photographs. The project nearly dies. It is saved by one man, Sir Wilfrid Freeman, 53 years old, Vice Chief of the Air Staff. Freeman has spent the war rescuing programs from bureaucrats. He rescues this one. He finds 5 Mustangs. He orders them delivered to Hucknall. Rolls-Royce will convert them. He arranges quietly for 2 of the converted aircraft to be flown down to General Carl Spaatz, commanding the American 8th Air Force in England, so that the Americans can see for themselves what the airplane can do. The first conversion, serial AL-975, flies on the 13th of October, 1942. A Rolls-Royce test pilot named Ronald Shepard is at the controls. The airplane climbs and climbs and climbs. 433 miles per hour at 22,000 feet. Absolute ceiling, 40,600 feet. Nothing the RAF flies climbs that high that fast. 6 weeks later, on the 30th of November, 1942, at Inglewood, California, a North American aviation test pilot named Bob Chilton, 29 years old, takes off in an aircraft called the XP-51B. The engine is a Packard V1650-3. The airframe is a P-51 modified to accept it. Chilton stays up for 45 minutes. He lands, gets out, walks to the office, and reports that the airplane performs. 2 continents, 2 prototypes, 7 weeks apart. To this day, the question of which side thought of it first, whether the idea belonged to Harker at Duxford or to men in Washington and Inglewood, who had reached the same conclusion independently, is argued in books and journals. The sources disagree. What is certain is that by December 1942, the Merlin Mustang existed on both sides of the Atlantic, and both sides knew it worked. Then the American prototype broke. A chemical reaction between the different metals in the coolant system and the ethylene glycol coolant itself clogged the radiator. The XP-51B overheated. The second prototype required a redesigned radiator core and a redesigned intake scoop. The problem was solved, but it was a reminder that translation is not free. Every change carries risk. Every improvement can fail on the first attempt. There was another problem, and it did not live inside the engine. His name was Tommy Hitchcock, Lieutenant Colonel Thomas Hitchcock, Jr., 42 years old in 1942. American from Aiken, South Carolina, and Long Island, and Paris, and everywhere the American ruling class went between the wars. In 1917, at 17, he had lied about his age and joined the Lafayette Flying Corps in France. He had been shot down, captured, and had escaped from a German prison train by jumping through a window at night. He had walked more than 100 miles across occupied Europe at night alone to the Swiss border. Between wars, he had become the greatest polo player in America. A 10-goal handicap, the maximum. F. Scott Fitzgerald, who knew him, put pieces of him into 2 novels, Tom Buchanan in The Great Gatsby. Tommy Barban in Tender is the Night. After that, he became a partner at Lehman Brothers. When the Second War came, Hitchcock was 41 and wanted to fly fighters. The Army Air Forces told him he was too old. He used what he had. Connections. He was commissioned a lieutenant colonel and sent to London as assistant air attaché at the American Embassy. The ambassador, John Wienant, had been a classmate at St. Paul's School. Hitchcock's job was liaison. What he became was an advocate. He watched the British test the Merlin Mustang. He read the numbers. He flew the airplane himself, and he began to write reports to Washington, dozens of them, arguing that the American 8th Air Force was about to fight a war it could not win unless the Merlin Mustang was ordered in mass production immediately. Washington resisted. Wright Field, the Army Air Force's engineering center in Ohio, did not want a British engine in an American fighter. There were domestic engines to develop. There were careers attached to those engines. Hitchcock wrote a phrase in one of his memos that captured the whole political problem in 20 words. Sired by the English out of an American mother, the Mustang has no parent at Wright Field to appreciate and push its good points. He went around Wright Field. He went to Robert Lovett, Assistant Secretary of War for Air, who, like Hitchcock, had flown in the last war. Lovett listened. The orders came, 2,200 P-51Bs. Then more. And while Hitchcock argued in Washington and Harker flew at Duxford and Vincent drew in Detroit, the plant on East Grand Boulevard turned into something none of them could have predicted. It turned into a battleground. By the spring of 1943, the Packard plant was running 3 shifts, roughly 40,000 workers. Many were women, many were black, having come north from Alabama and Mississippi and Georgia looking for the wages a defense plant could pay. The war had emptied Detroit of white men young enough to fight. It had filled Detroit with everyone else. The federal government, through executive order, required defense contractors to integrate. Packard did the minimum. In the spring of 1943, Packard promoted 3 black workers, according to most sources, though a few say 2, to positions on the aircraft engine assembly line, positions previously held only by white men. On the 3rd of June 1943, roughly 25,000 white workers at the Packard plant walked off the job. They did not walk off over pay. They did not walk off over hours. They walked off because they refused to work beside black men on a production line building engines for the war against fascism. According to contemporary reports, a voice over the plant loudspeaker declared that it would be preferable for Hitler and Hirohito to win the war than to work next to a black man on the assembly line. The exact wording has been quoted many ways in the years since. The sentiment behind it is not in dispute. The strike lasted several days. The plant that was building the engine that would take American bombers to Berlin stopped building it. The United Auto Workers under Walter Reuther ordered the strikers back. The War Labor Board sent a telegram threatening dismissal. Roughly 30 of the strike leaders were suspended on the 6th of June. 17 days later, on the 20th of June, 1943, Detroit exploded. 3 days of race rioting, 34 people killed, 25 of them black, most of them killed by police. Federal troops restored order. The plant went back to work. The engines kept coming, 400 a week, then more. None of the men whose names have been in this story would have said the war was won by any one of them alone. Not Vincent in Detroit, not Hooker in Derby, not Harker at Hucknall, not Freeman in the Air Ministry, not Hitchcock in London. The engine existed. The airframe existed. The politics had at last been settled. The factories were producing. But over Germany, at 25,000 feet, the bombers were still going up without escort past the German border. At an air base in England called Boxted, a young American colonel named Don Blakesley, 26 years old, is standing on a tarmac. He has flown Spitfires for the Royal Air Force in one of the Eagle squadrons, American volunteers before Pearl Harbor. He has transferred into the United States Army Air Forces. He now commands the 4th Fighter Group. His pilots have been flying P-47 Thunderbolts, good airplanes, rugged, but short-legged. They cannot reach Berlin. In February 1944, new airplanes begin arriving on his flight line. Slim, long, painted in olive drab, under the nose no radial engine cowling, a pointed spinner, a chin scoop, and inside 12 cylinders in a V, built in Detroit, drawn by men who had never built an aircraft engine before the war. Blakesley looks at the airplanes. He turns to his pilots. He tells them they will learn to fly the Mustang on the way to the target. Berlin. For 2.5 years, the word had meant something no American pilot could deliver. Berlin was the deepest target in Germany. Berlin was where the war was being run from. Berlin was where the fighters that killed the bombers came from. And Berlin, from any airfield in England, was too far. That changed in the winter of 1943. The first Merlin Mustangs to reach a combat unit in Europe went to a group nobody in the American press had ever heard of, the 354th Fighter Group, newly formed, newly trained, commanded by a colonel named Kenneth Martin, Career Air Corps. The 354th arrived in England in November 1943 and was assigned, oddly, not to the 8th Air Force that was bombing Germany, but to the 9th Air Force that was preparing to invade France. The 8th had the bombers. The 8th needed the escorts. And so, by arrangement, the 354th flew for the 8th while wearing the shoulder patch of the 9th. On the 1st of December 1943, they were declared operational. On the 13th of December, they flew their first escort mission all the way to Kiel and back, and they lost no one. Berlin came in March. On the 4th of March 1944, weather over Germany was terrible, and most of the American formations turned back short of the target. A small group of B-17s pressed on. Above them, a handful of Mustangs from the 354th and the newer groups that had by then converted. That day, American fighters flew over Berlin for the first time in the war. Not many of them, not enough to matter. 2 days later, on the 6th of March 1944, the 8th Air Force sent nearly 700 bombers to Berlin, escorted most of the way by nearly 700 fighters, among them the P-47 Thunderbolts of General William Kepner's fighter groups, and at the front of the escort, running in low and fast over the German capital, the Mustangs of the 4th Fighter Group, led by Don Blakesley. The Luftwaffe came up in strength. The Americans lost 69 bombers that day. It was the worst single day of losses the 8th Air Force ever suffered. It was also the day they arrived over Berlin and stayed. Within a month, the ratio of losses had turned. Within 2 months, the Luftwaffe was hemorrhaging pilots faster than it could train new ones. Big Week in late February had already gutted the German fighter arm. Between January and April of 1944, according to figures compiled later by the historian Jeffrey Ethel, the Luftwaffe lost over 1,000 experienced fighter pilots. 28 of them had scored more than 30 kills. 8 had scored more than 100, men who had flown since Spain, since Poland, since France, disappeared in the cold March skies over their own country. The Merlin Mustang did not win that fight alone. The P-47 did much of the work. The bombers themselves did much of the work. But without the Mustang, the fight could not have been carried to Berlin at all. The engineering reason came down to numbers few people bothered to look at. A P-47 Thunderbolt, according to Ethel's figures, got roughly 1 8/10 miles per gallon. A P-51B on the same fuel got roughly 3 3/10, almost double. The difference was not the fuel tanks. The Mustang carried about the same internal fuel as the Thunderbolt when it left the factory. The difference was the airframe, the Meredith duct feeding the radiator, and the Merlin. 2-stage, 2-speed, intercooled, efficient at high altitude in a way no American engine of that era could match. The Mustang did not have long range because it carried more fuel. The Mustang had long range because it burned less. That was the secret Detroit had been protecting without knowing it. That was what Colonel Vincent and his 200 draftsmen had spent 1941 preserving when they redrew the blueprints. Not just the horsepower, the efficiency. Every 10,000th of an inch they held on the impeller casting, every improvement in the bearing metallurgy, every tightening of the tolerances was insurance on that fuel economy at 30,000 feet. Later, as the war moved into 1944, Packard introduced the V-16 5-7, tuned for the lower altitudes where much of the actual combat was happening. That engine went into the P-51D, the airplane most Americans picture when they hear the word Mustang. Bubble canopy, 650 caliber machine guns, 1,490 horsepower for takeoff. By VE Day, more than 15,000 Mustangs had been built, and in the noses of the great majority of them, a Packard Merlin. The man who had fought hardest to put that engine there did not live to see it finish the job. In early 1944, as Mustangs began flying combat, reports came back from the field of a problem in the airplane. Something about it that killed pilots without warning, under certain conditions in a high-speed dive, particularly with external fuel tanks still hanging under the wings. The Mustang would refuse to pull out. It would keep diving straight into the ground. Tommy Hitchcock, by then a lieutenant colonel and deputy chief of staff of the 9th Air Support Command in charge of tactical research and development, took the problem personally. It was his airplane. He had spent 2 years arguing for it. He would not delegate its dive test to a younger pilot. On the morning of the 18th of April, 1944, he climbed into a Mustang at an airfield near Salisbury in Wiltshire, England. He took the airplane up to 15,000 feet. He put it into a dive. He did not pull out. The Mustang went straight into the ground. Witnesses saw a plume of oily black smoke against the sky. He was 44 years old. Ambassador Winnett, the classmate from St. Paul's, sat down and wrote the letter to Hitchcock's wife and children. He told them that the Mustang, in his words, was tangible evidence of Tommy's contribution to victory, and that without it, the air war over Germany could not be won. 7 weeks later, on the 6th of June, 1944, the Allies landed in Normandy. Over their heads, from first light to last, Mustangs flew cover. Hitchcock had been right about all of it. He had died proving it. There is one more thing this story owes you. The Packard Merlins did not just go into American airplanes. That has to be said clearly, because it is the piece of the story that closes the circle. Packard Merlins went into Avro Lancaster heavy bombers built in Britain. Packard Merlins went into Mosquito twin-engine attack aircraft, wooden airplanes made in Canada and England. Packard Merlins went into the Supermarine Spitfire 16, which was mechanically a Spitfire 9 with a Packard-built Merlin 266 under the cowling instead of a Rolls-Royce Merlin 66. Packard Merlins went into Hurricanes assembled in Ontario, American engines drawn in Detroit by men who had never built an aircraft engine, flew back to Europe inside British and Canadian airframes to finish the job. By the time the last engine came off the East Grand Boulevard assembly line in 1945, Packard had built 55,523 Merlins, roughly a third of the total Merlin production of the war. The rest, close to 2/3, was built by Rolls-Royce and its associated plants in Britain. Derby, Crewe, Glasgow, Ford at Trafford Park, the two great manufacturing traditions of the 20th century, one obsessed with craftsmanship, one obsessed with interchangeability, had built the same engine on two continents at the same time. And it had worked. None of the men who built it went home to what they expected. Colonel Jesse Vincent retired from Packard in 1946. He had spent 5 years, from June 1940 to the last engine in 1945, on this single project. He lived until 1962. Ronnie Harker, the man whose 30-minute flight had started everything, stayed at Rolls-Royce after the war. He wrote a memoir. He was called, for the rest of his life, the man who put the Merlin in the Mustang. He lived to see the airplane he had inspired become the most valuable warbird in the collector's market. He died in 1999, 90 years old. Sir Stanley Hooker, the mathematician who had designed the supercharger that made the whole thing possible, went on to work on jet engines. In the 1970s, when Rolls-Royce nearly collapsed under the weight of the RB211 turbofan program, they called Hooker back out of retirement to save the company. He did. He was knighted. He died in 1984. Sir Wilfrid Freeman, who had saved the Merlin Mustang from the Air Ministry's own bureaucracy, retired shortly after the war. He is remembered today mostly by people who read the footnotes. And Packard, the company that had built more Merlin engines than any factory in Britain, that had turned Detroit into the arsenal it had promised to be, did not survive the peace. Automobile buyers in the 1950s wanted lower, longer chromed. Packard's engineering culture was the wrong culture for that market. In 1954, Packard merged with Studebaker. The last car to wear the Packard name rolled off the line in 1958. By the early 1960s, the plant on East Grand Boulevard was closing section by section. Today, that plant is one of the most photographed industrial ruins in America. Nearly 3.5 million square feet of concrete and brick and empty window frame on the east side of Detroit. Trees grow through the roof in places. The floors of the Merlin assembly halls, where 55,000 aircraft engines once left for the war, are open to the sky. If you go there, and you can, though it is dangerous and much of it is fenced, you can stand on the concrete where the test stands used to be. In the summer of 1941, on the 2nd of August, that concrete carried the vibration of the first Packard-built Merlin as it ran up on the test bed. The men standing around it in shirt sleeves in the Detroit heat did not know they were about to build 55,000 more. They did not know that in less than 3 years, one of their engines, mated to an American airframe and pointed east from an airfield in Essex, would carry a young man named Don Blakesley over the Reichstag at midday. They only knew that the engine ran. The secret of the P-51 was never a single part. It was not the indium plating on the bearings. It was not the Bendix carburetor. It was not the two-piece cylinder block or the intercooler or the impeller balanced within a 10,000th of an inch. The secret was the translation itself. The radiator scoop under the belly of the Mustang came from a British engineer at Farnborough named Meredith in 1935. The engine came from Derby in 1933, refined by a mathematician from Oxford who had never touched an aero engine before he walked into the factory. The mass-produced version of that engine came from a luxury car company in Detroit, drawn in the language of the American assembly line by men who had, until 1940, built limousines for bankers. The airframe came from California, built in 117 days for a customer 3,000 miles away. And the young men who flew it into the sky over Germany came from Ohio and Texas and Nebraska and Michigan, and in the case of Don Blakesley, from Fairport Harbor, Ohio, by way of a Royal Air Force squadron he had joined before his own country was in the war. Americanized in the title of this story does not mean owned. It does not mean improved. It does not mean claimed. It means translated, faithfully, under pressure, in time. The next time you hear a Merlin at an air show, that low, hard, unmistakable growl at full throttle, listen for what is inside it. 2 continents, 2 decades of engineering, 2 philosophies of how a thing is made. A supercharger designed in Derby, a bearing perfected in Detroit, a radiator worked out in Farnborough, and a wing drawn in Inglewood. And somewhere in that sound, if you listen carefully, 44 years of Tommy Hitchcock's life. 30 minutes of Ronnie Harker's flight over Duxford. 200 draftsmen bent over their tables on East Grand Boulevard. 25,000 men who walked off that same shop floor in June of 1943 for reasons that had nothing to do with the war and everything to do with who their country still was. 600 B-17 crewmen who did not come home from Schweinfurt, all of that in one engine, running at cruise. That is the secret of the P-51.